Hello, Honors Algebra 2. All right, so what we're going to do here is I'm going to break up each of these problems to have their separate video, and I am going to talk about how to prove each of these by working on the left side and on the right side. So you were encouraged to just watch the part of the video you need to, but I did want to have everything that I have on the note sheet on Canvas on video for you to watch. If you would like to. So before we start with number one, just a couple of reminders. You have your difference of squares, which we should be able to factor pretty easily. But then we also have difference of cubes and sum of cubes, which is not something we've dealt with a whole lot besides first semester. So as a reminder, difference of cubes factors like this: a minus b times the quantity of a squared plus ab plus b squared. So keep, change, plus, if you remember with your signs. So then sum of cubes, we have a plus b, so keep, change, so you'll have a minus, and then always plus. All right, so there are your factoring reminders. Now let's go ahead and try number one. So this line here is to separate the two different ways to do this. The first one I'm going to do is the way that actually takes the longest. I'm going to change the right side. So if you don't feel like changing the right side and you want to change your left side, you do want to jump ahead in the video to find the other way to do this. But I'm going to start by changing the right side. Keep in mind, again, you always want to keep the other side written down. Okay, because it is a proof, you do need to have both sides equal at all times. So the first thing that I'm going to do with this one, I notice that I have a sine of x as my denominator. I want to have my denominator be a 1 plus cosecant x. So let me just rewrite this first. So if you need a 1 plus cosecant x in the denominator, then let's just multiply 1 plus cosecant x on top and bottom. And then as you've been able to see the past few days, there are really so many different ways to do these problems. So this is just one way that made sense to me, but I'm sure there are other ways as well. All right, so I'll bring this down. And I know it's a pain, but yes, you need to do it. So what I'm going to do now is, what you probably didn't want me to do, is FOIL this. So when we FOIL, we're going to have 1 times 1 is 1 plus cosecant x minus sine x minus sine x cosecant x over, I am not going to distribute the bottom. Reason being, you want to have a 1 plus cosecant x. You have a 1 plus cosecant x now. We're going to basically need to find some way to cancel that sine of x out. Distributing doesn't do anything for you, but change your denominator away from what you want it to be. So leave the bottom as sine of x, 1 plus cosecant x. Because this part, oops, that's not what I wanted. There. This part here is what we want to stay. Okay, that's what we want. All right, so next, what you should hopefully notice is that you have an identity here. Sine x times cosecant x is really just 1. And that's because cosecant x is 1 over sine x. So sine of x times 1 over sine x is 1. And then you have this one here, 1 minus 1, that will cancel out. So what we really have left is our 1's are canceling. We just have a cosecant x minus sine x on top now. And again, we're going to leave the bottom as is because I want that 1 plus cosecant x. All right, next. Rewrite. Okay, so the next thing I'm going to do is I'm actually going to change that cosecant x to a 1 over sine x because I'm thinking that maybe I can get this part here to one fraction. And because when you have fractions, usually things start canceling out more. So I'm going to try to change cosecant x minus sine x to all sines and see what happens. And honestly, sometimes with these, you guys, it's just kind of see if it works. And if it doesn't, you try something else. I do think that you will probably like the second way that we do this better. But we started this way, so we're going to finish it. All right, so on your top, you now have 1 over sine x minus sine of x. I'm going to put this over 1. I'm going to get a common denominator with this whole portion right here. In order to do that, I'm going to multiply my sine of x over 1 by sine of x over sine of x. That will give me a 1 over sine of x minus sine squared x over sine of x. And now we have 1 minus sine squared x over sine of x. And some of you are going to see right away what we can already do with that. 1 minus sine squared x, this is one of our big Pythagorean identities. This we can change to cosine squared x. So now I'm going to do that. And I am running out of room. So I have cosine squared x over sine of x over sine of x 1 plus cosecant x. Okay, so now let's take this part. Let's see if we can rewrite this. This is the same as cosine x over sine of x. And what you should notice is that cosine x over sine of x is cotangent x. And that is important because we do have this cotangent x, cotangent squared x up at the top. Over all right. Hopefully you're writing smaller than I am. So now I have cotangent x, cosine x over sine x 1 plus cosecant x. All right, so next. What you should also notice is that you still need a cotangent squared x, and we only have a cotangent x. So just like at the beginning, we said, hey, I need a 1 plus cosecant x up here when we multiplied by 1 plus cosecant x. I still need a cotangent. So let's multiply by cotangent x on top and bottom. That gives you a cotangent squared times cotangent cosine x. When you do sine times cotangent, cotangent is the same as cosine over sine. So what's going to happen is your sine of x's will cancel and you are just left with cosine x. And then finally your cosine x's will cancel. And you are left with this. Hooray! We are done. It only took us 10 minutes to do this one. Okay, so now let's erase everything that's on this side and try it the much faster way. All right, this way is going to be faster, I promise. All right, so let me rewrite the problem first. So this time we are going to change the left side, which probably makes the most sense. Because what you can do with the top here, and right here, is you can factor that. We can just do difference of squares. I think this is probably the most obvious way to do this, because then you should notice you should have some cancellation occur pretty much right away. So I'm going to do cosecant x plus 1, cosecant x minus 1 over, I'm just going to switch the order on that, cosecant x plus 1. And then you're going to see, oh, hey, these guys cancel. So now I have cosecant x minus 1 equals 1 minus sine of x over sine of x. So now what you've got to think is, all right, cosecant x minus 1, that needs to become a fraction. So let's rewrite this. Cosecant x minus 1 is just 1 over sine of x minus 1. And then this is one fraction, so we need a common denominator, sine of x over sine of x. So now I have 1 minus sine of x over sine of x. And everyone says, well, why didn't we do that to begin with? Hey, I wanted to show you both ways. All right, so this would be, I think, the method that makes the most sense. However, I mean, you can work with the right side. It's a huge pain. So maybe don't do that. Work with the side that looks like you can factor it and that things will cancel out. All right, okay, so there's number 1. And next, I will be going to number 2, but I'm going to do that in a different video. So if you want to see how to do number 2, go ahead and stop this video, go on to the next one. See you later.